groups. If there is a lone pair groups and electronegativity groups in Cram's open chain model at chiral center, there is no lone pair groups and electronegativity groups. Only large, medium, small groups are present. Only large, medium, small groups are present. At chiral center, only large, medium, small groups are present. Only large and small groups are present. So I'm taking this molecule. In this molecule at chiral center, there is no lone pair groups and electronegativity groups. Only large, medium, small groups are present. When this molecule I'm converting into in this molecule I'm converting into conformational model. In this conformational model, so visualization from this, visualization from bottom side. So bottom carbon, so it is a chiral carbon, medium, small, a large group, and carbonyl carbon and alkyl group. So in this case, so when we am rotating, in this case, this in this Cram's open chain conformer. This is a Cram's open chain conformer. In this Cram's open chain conformer, large group at chiral center and carbonyl group. Large group at chiral center, carbonyl group are anti to each other. Large group at chiral center, carbonyl is large anti to each other. Anti to each other. Large group at chiral center and carbon are anti to each other. Large group chiral center and carbonyl carbon are anti to each other, and carbonyl large group at chiral center, carbonyl attached groups. Large group at chiral center, carbonyl attached groups are eclipsed to each other. This is a Cram's open chain conformer. In Cram's open chain conformer, a large group at chiral center and carbonyl group are anti to each other, and a large group at chiral center, carbonyl attached carbonyl attached group are eclipsed to each other. When this compound reacting with when this compound reacting with when this compound reacting with electrophilic when this compound react with nucleophiles, this time taken Grignard reagent nucleophiles. When I'm taken Grignard reagent nucleophiles, Mg plus or minus, this approaching from small side group side only. This approaching from small group side only. This is sterically free. If it is that approaches from medium group side, it is steric crowding is there. Therefore, approaching from small group side is a free. Therefore, the resulting product is R small, Rm, R large here. The approaching alkyl group, here going to hydroxy group, here R data group. I am writing this is a conformation mod is R OH R R dash when it is RM RS RL. This is a major diastereomer will be formation takes place. This is a major product will be formation takes place. This is a Kram's open chain model. In this Kram's open chain model, at Chiral Center, there is no lone pair groups and electronegativity groups present. Only large, small, medium groups are present. So this is will be the Kram's open chain model. Second one is Kram's cyclic model. In this Kram's cyclic model, in this Kram's cyclic model, in this Kram's cyclic model, at chiral center, in 1 comma 2 asymmetric synthesis participate starting material at chiral center, lone pair groups are must be present. Lone pair groups are must be present. Okay. At chiral center, whatever the molecule participate in 1 comma 2 asymmetric connection at chiral center, lone pair groups are must be present. Lone pair groups are must be present. Okay. Lone pair groups are must be present. So just I'm taking one example here. Just I'm taking one example. Phenyl, here phenyl and phenyl carbonyl hydroxy and phenyl methyl. This is example I am taken here. When this molecule I am writing into conformer, I am writing into our conformer conformation structure. I am writing into conformation structure here. That is a OH. Here OH. I am writing OH here and methyl here, phenyl, methyl and phenyl. So here that carbonyl carbon here and that phenyl is here. In this Kram's cyclic model, lone pair containing group and carbonyl oxygen, lone pair containing group and carbonyl oxygen are eclipsed to each other. Lone pair containing group and carbonyl carbon are must be eclipsed to each other. And carbonyl carbon is flanked in between large and small medium group side only. Large and medium group side only. That is the carbonyl carbon flanked in between large and medium group. When reacting with the lithium aluminum hydride, this lithium aluminum hydride, aluminum forms hydrogen bonding with lone pair groups and carbonyl oxygen. So therefore, so when aluminum hydride, so this aluminum forms hydrogen bonding with lone pair group and carbonyl carbon. Therefore, they forms 5 member ring will be formation takes place. 1, 2, 3, 4, 5 member ring will be formation takes place. This aluminum hydride releases hydrogen from small group side only. Small groups means medium group side only. Medium group side only. This is a sterically free path. Therefore, the resulting product is. Therefore, the resulting product is. Therefore, the resulting product is OH, phenyl, methyl. Again here, hydrogen reacting with hydrogen H. It is coming to that is OH and here phenyl. Okay. So I'm writing this into eclipsed model. This is anti-model, eclipsed model. I'm writing in the form of eclipsed OH, phenyl, methyl, phenyl. Here OH and here OH, here hydrogen, here phenyl. Okay, this is I am writing this molecule to Fisher. I'm writing to Fisher. Here methyl and hydrogen are downside. Methyl hydrogens are downside, and one is methyl hydrogens are down and OH, here phenyl, here phenyl. This is a major diastereomer will be formation takes place. This is a Kram's cyclic model. This is a Kram's cyclic model. This is a this is a Kram's cyclic model conformer. Okay, in this Kram's cyclic model, large group in this Kram's cyclic model at chiral center there is in the Kram's cyclic model at chiral center there is no lone pair groups. In Kram's cyclic model there is no lone pair groups. Sorry. In Kram's cyclic model there is a lone pair group P must be present. In Kram's cyclic model there is a lone pair group must be present, and when we convert it into the Kram's cyclic model conformer, lone pair group and carbonyl oxygens are lone pair group and carbonyl oxygens are eclipsed to each other and eclipsed to each other. So when reacting with lithium aluminum hydride, the aluminum forms a hydrogen bonding with carbonyl oxygen and lone pair group. There is a five-membered ring will be formation takes place. There is a five-membered ring will be formation takes place. Lithium aluminum hydride releases the hydrogen from medium small group or medium group side only. Then corresponding diastereomer will be major will be formation takes place. Next one is Felkinan model. Next one is Felkinan model. Next one is Kram's dipolar model. Next one is Kram's dipolar model. This Kram's dipolar model at chiral center, at chiral center only electronegativity groups are present. Okay. In Kram's dipolar model, at chiral center only electronegativity groups are must be present. In Kram's dipolar model, at chiral center only electronegativity groups are present. Okay. I am taking one example here. R small, R large, X. I am writing into a conformer. Here, R, S, R large, and X. This is a Kram's dipolar conformer. Conformer. In this is Kram's dipolar conformer. In this Kram's dipolar conformer, carbonyl group and electronegativity group. Carbonyl group and electronegativity group. In Kram's dipolar model, carbonyl group and electronegativity groups are anti to each other. Kram's group in Kram's dipolar model, carbonyl group and electronegativity groups are anti to each other. Due to this anti arrangement, carbonyl carbon getting more electron deficient. Due to this due to this conformer, the carbonyl carbon getting more electron deficient when reacting with nucleophile. When reacting with nucleophile, it's a metal nucleophile. When reacting with nucleophile, the nucleophile approaches the carbonyl carbon from small group side only. The approaching from carbonyl carbon small group side only. This is a sterically free form. This is sterically free form. Therefore the product is XR plus R large, and this is R. We are going to H here R. Okay, R dash R dash. So I'm writing this is a major product will be formation takes place. This is a major product will be formation takes place. Just I'm taken specific. This is a common example. I'm taken specific example. Tertiary butyl carbonyl ethyl hydrogen chlorine. In this molecule in the form of Kram's dipolar model, Kram's dipolar model, Kram's dipolar model, ethyl hydrogen chlorine, C double bond O, N butyl. In this model, when this compound reacting with sodium borohydride, sodium borohydride, but the sodium borohydride, this is a large group, this is small group. Sodium borohydride releases the hydrogen from small group side, corresponding small group side only. Therefore, that is the product will be hydrogen ethyl chlorine. Here hydrogen, here OH, here N-butyl, here N-butyl. The product I am writing into Fischer form. I am writing in the form of Fischer form. That is, I am writing in the Fischer form. N-butyl, ethyl, OH, H, chlorine, hydrogen. This will be major product will be formation takes place. This is a major product will be formation takes place. Okay. So this is a Cram's dipolar model. This is a Cram's dipolar model. This is a Cram's dipolar model. Felkingham model. This is alternate to the Cram's open chain model. It is alternate to the Cram's open chain model. In this Felkingham model, at chiral center there is no lone pair groups and electronegativity groups. There is no in lone pair groups and electronegativity groups. In Felkingham model, this Felkingham is alternate to the Cram's open chain model. At chiral center, there is no lone pair groups and electronegativity groups are present. Okay, there is no electronegativity groups. So with only large, medium, small groups are present. Only large, medium, small groups are present. Just I am taking one example. R, R medium, R large, small. When this molecule I am writing uh, in the conformer here, uh, carbonyl here R, here R, and this is the R medium, R small, R large. So according to Felkingham model, the carbonyl oxygen and large group at chiral center, carbonyl oxygen and large group at chiral center must be at 90-degree separation. That means 90-degree separation must be present. 90 degrees separation must be present. Therefore, I am rotating the molecule. I am rotating the molecule in this form. Or sorry, carbonyl or this is the formation. Okay, RM RS, RM RS, RM and RS. So when RM and RS, this is a major. R, if I am rotating like this, if I am rotating like this, here R large, here RS, RM. Okay, compared to this one is stable. Compared to this one is stable. Compared to this conformal is stable. This compared to this conformal is stable because here carbonyl oxygen is flanked adjacent to the medium group. Here carbonyl oxygen flanked adjacent to the small group. Therefore, this is a stable one. This is unstable. When this molecule when this molecule reacting with when this molecule reacting with uh, then this molecule reacting with lithium aluminum hydrate. Lithium aluminum hydrate releases the hydrogen ion from carbonyl side. Then the product is then the product is R R small R medium when here R hydrogen OH R. Okay, this is a major conformation will be formation takes place. This is a major will be formation takes place. I am explain with the specific example. When tertiary butyl, I am explain with the specific example. When tertiary butyl, carbonyl, methyl hydrogen methyl hydrogen phenyl. So I am writing in the Felkinan conformer. I am writing in the form of Felkinan conformer. Here phenyl, here methyl, here hydrogen will be formation takes place, and here carbonyl, here tertiary butyl. This one is reacting with lithium aluminum hydrate. This one is reacting with lithium aluminum hydrate. Lithium aluminum hydrate releases the hydrogen from so 107 degree separation. 107 degree of separation. 107 degree of separation. Therefore, the corresponding one is phenyl, methyl, hydrogen. Here hydrogen going to OH, going to tertiary butyl. Tertiary butyl. When it is writing in the form of eclipsed one, hydrogen, phenyl, methyl, here tertiary butyl, here OH, here H. I'm writing in the form of Fischer form, tertiary butyl, OH, hydrogen, phenyl, hydrogen, methyl. This is a major diastereomer. This is a major diastereomer way formation takes place. This is the substrate control asymmetric synthesis. So in this substrate control asymmetric synthesis, these Cram's rules are very, very important. Cram's rules and Felkman model. These four are very, very important. Cram's rule is the Cram's is the scientific to predict the major diastereomer formula in the 1,2 asymmetric induction. This 1,2 asymmetric induction are classified into three types: Cram's open chain model, Cram's cyclic model, Cram's dipolar model. Cram's open chain model. At chiral center, there is no lone pair and electronegativity groups. In Cram's cyclic model, at chiral center, there is a electronegativity groups. In Cram's dipolar model, there is a electronegativity groups are present. So this is a Cram's dipolar model. And in the Felkiran model, it is alternative Cram's open chain model. So this that in this Felkiran model, large group at chiral center is 90 degree to separation of carbon and oxygen, and the resulting conformer that nucleophile approaches to the carbon and oxygen from 107 degrees only. The resulting product will be diastereomer, will be formation takes place. These are the substrate controlled asymmetric synthesis. Thank you.